Hi, Bob Rasooli, Orange County, California. In this video, we are going to cover MOC and what you should know for the API 570 exam. MOC is one of those topics that students sometimes overlook, but it is clearly addressed in the code, and it plays a critical role in refinery and petrochemical operations. What is MOC in the context of API 570? MOC is the formal process for reviewing and controlling modifications to process systems, including piping and piping components. API 570 recognizes MOC as a vital part of the owner-operator's integrity program. The intent is clear. If you make a change to the piping system, whether it is a physical modification, a change in service, or even an adjustment in process parameters, you must evaluate how that change will affect piping integrity and the inspection plan. The exam expects you to know that MOC is not optional. API 570 specifically states that the owner-operator must have an effective MOC process that covers piping and associated components. Both inspectors and reliability engineers are expected to be part of that process. Why is MOC so important? Because uncontrolled changes are a frequent cause of unexpected failures. A piping system might be designed, inspected, and maintained for a defined service. If that service changes, say by introducing a different process stream or operating at higher temperatures, new damage mechanisms may become active. Without MOC, those risks may not be recognized until a failure occurs. MOC provides a structured review. It ensures that inspectors, reliability engineers, corrosion specialists, and piping engineers all have a chance to assess the implications before the change is implemented. Now, let's walk through what the code requires. An effective MOC process must allow the inspection and reliability teams to review the adequacy of the piping design and the current condition when a change is proposed. It must anticipate changes in corrosion or other damage mechanisms that might result from the change. And it must update inspection plans and inspection records to reflect those changes. API 570 also emphasizes that materials and corrosion expertise must be involved in forecasting the impacts of change. This is not meant to be a purely administrative exercise. Technical input from the right specialists is required, and importantly, the scope of MOC is broad. It applies not just to process condition changes, but also to modifications of pipe components, supports, or associated systems. Even small adjustments, such as swapping out a valve for a different material grade or modifying a support configuration, require MOC review. Consider a hydrocracker unit. If operations decides to increase throughput and raise reactor outlet temperatures, that decision directly affects piping integrity. Higher outlet temperatures can accelerate creep or high-temperature hydrogen attack. Without MOC, inspection intervals might continue unchanged, while damage rates quietly increase. With MOC, inspectors and reliability engineers review the situation, adjust the inspection plan, and add monitoring for those circuits. In an FCC unit, slurry systems are prone to erosion corrosion. Installing a new quench injection point could change flow dynamics and increase wear at a downstream elbow. An effective MOC ensures that this elbow is identified as a new monitoring location, and inspectors schedule thickness checks there going forward. Even in more routine cases, MOC applies. Imagine a reformer unit where a piping spool is replaced during a turnaround. If the replacement is made from a different alloy, say stainless steel instead of carbon steel, the damage mechanisms change. Chloride stress corrosion cracking risk may now exist. Through MOC, the inspection and reliability teams identify this and update the plan to include monitoring for that mechanism. For the exam, you don't need to know a detailed corporate MOC procedure, but you must understand the core points that API 570 makes. The owner-operator must have an effective MOC process. Inspectors and reliability engineers must be directly involved in evaluating changes that affect piping integrity. The MOC process must address design adequacy, anticipate new damage mechanisms, and update inspection plans and records. Materials and corrosion expertise must be part of the review. And the scope includes not only process changes, but also changes to components and supports. These are the elements exam questions are most likely to test. The bottom line. MOC is about ensuring that no modification is made without understanding its impact on piping safety and reliability. For the API 570 exam, remember that MOC links process changes directly to inspection and reliability activities. If the service changes, the inspection plan changes. If components or supports are modified, they must be reviewed. And if new damage mechanisms are introduced, they must be anticipated and monitored. That is what you should know about MOC in the API 570 exam.